Hello my dear students, in this lecture we are going to see few numericals on properties of fluid. These are some theoretical questions which were asked in previous year GATE examinations. Now very first question is asked in GATE 2018 for 1 mark in set 1. We will see this question. Now question is, which one of the following statement is correct for superheated vapor? Now there are 4 statements and which of the following is the correct statement for superheated vapor? This is a question, right? Now options are, its pressure is less than saturation pressure at a given temperature, its temperature is less than saturation temperature at a given pressure, its volume is less than volume of the saturated vapor at a given temperature, its enthalpy is less than enthalpy of saturated vapor at a given pressure. Now out of this 4 statement, option A is correct statement. Option A is correct statement. Let us understand this option A. My dear students, if I draw temperature versus entropy diagram, let us draw temperature versus entropy diagram, right? On this temperature entropy diagram, there will be a liquid vapor dome and the constant pressure lines. Let us draw constant pressure lines. Let us draw one constant pressure line. P1 is constant, then constant pressure line will look like this. This is a constant pressure line. Let us say on this line pressure P1 is constant. Pressure P1 is constant. The temperature at which there is a phase change is called saturation temperature. Therefore corresponding to this P1, this is the first pressure P1 constant. The saturation temperature is here. This is a T sat 1, right? Here this temperature we can say saturation temperature 1, T sat 1 over here, right? Now my dear students, let us draw another constant pressure line at higher pressure. Now let us say another constant pressure line at higher pressure like this, right? Now this line is P2 is equal to constant. P2 is equal to constant. Now for this constant pressure line, the saturation temperature 2 is nothing but here. This is a T sat. That is that during phase change, the temperature is called saturation temperature and the corresponding pressure is called saturation pressure, right? So my dear students, here we know that T sat 2, here saturation temperature 2, T2 is more than T1, hence this P2 is more than P1. P2 pressure 2 is more than pressure P1. Now my dear students, therefore the saturation temperature is somewhere here for 2 condition. Now let us extend this line. If I extend this saturation temperature line, right, then I will get here some point where let us say this is a point 3. Now can I say T2 is equal to T3? Can I say T2 is equal to T3? And my dear students, at a 3 point, but P2, but P at 3 point, P3 is pressure 1, at 3 point pressure is 1, right? And P1 is less than P2. My dear students, 3 point is in superheated state. Are you able to imagine or not? This 3 point is in superheated state, but the pressure at 3 is less than the saturation pressure for 2, right? Here saturation temperature and the corresponding pressure is called saturation pressure. Therefore this pressure is called saturation pressure also, right? T sat 2 and P sat 2, we can say P sat 2, right? Therefore this P2 is more than P3, means here we can say P3 is less than P2. That means pressure is less than saturation pressure, because at temperature T2 or T3, T2 is equal to T3. At temperature T3, the saturation pressure is P sat here, but we have pressure less than P sat. We have pressure less than P sat. Therefore, whenever pressure is less than saturation pressure, then the mixture will be in superheated state. Option A will be the correct choice. Now, next theory question on this topic is, this question was asked in GATE 2016 for 1 mark in set 3. The question is, the incorrect statement about the characteristics of critical point of a pure substance is. Now here they are asking what is the incorrect statement for critical point, Now before understanding all the statements, let us understand the critical point first, right? Now my dear students, let us see the critical point. Here critical point is nothing but the point where saturated liquid line and saturated vapor line meets. If I draw pressure versus volume diagram, on pressure versus volume diagram, here the liquid vapor dome will be like this, and the peak point, here the peak point is called critical point. This peak point is called critical point. Now my dear students, to the left, this line is called, to the left of this critical point, this line is called saturated liquid line. Here this line is saturated liquid line, saturated liquid line, and on this line dryness fraction is 0, quality is 0, right? And my dear students, to the right side of this critical point, this line is called dry saturated vapor line, dry saturated vapor line, vapor line, and on this line dryness fraction is 1. And my dear students, for saturated liquid line, as volume is increasing, pressure is also increasing, therefore the slope of saturated liquid line is positive, right? And for dry saturated vapor line, as pressure is decreasing, volume is increasing, therefore slope of saturated vapor line is negative. Therefore critical point is a point where saturated liquid line and saturated vapor line meet. See the option 4, saturated liquid and saturated vapor line states are identical. Yes, exactly. At critical point, saturated liquid line and saturated vapor line meet, means saturated liquid line and saturated vapor states are identical. Therefore option D is correct, right? Option D is correct, but they are stating which is incorrect. Therefore option D is not a choice. Here option D is not your answer. What I am saying, option D is not answer means option D is correct statement. They are asking you incorrect statement. Now again, at critical point, positive slope becomes negative slope, means to become positive slope into negative slope, the slope must be 0 first. Therefore at critical point we can say slope is 0, slope is 0, right? Therefore, and always zero slope point is called point of inflation. Therefore critical point is also called point of inflation or zero slope point. Therefore look at the option B, it has a point of inflation with zero slope. Hence we can say statement B is also correct, but they are asking which is incorrect statement. Therefore statement B is also not a choice, right? Now again, as the pressure goes on increasing, this line is called latent heat, right? The phase change from saturated liquid state to saturated vapor state, the line is called phase change line. Now as pressure goes on increasing, the latent heat goes on decreasing, and at critical point latent heat becomes 0, means latent heat is 0 means there is no constant temperature phase change process, right? Therefore option A, there is no constant temperature vaporization process, right? Therefore option A is also correct statement. Option A is also correct statement, but they are asking which is incorrect statement. Therefore option A is not possible, right? Now see, inside this left side of this curve is nothing but liquid state. Therefore here there is a liquid state. In this dome there is a liquid plus vapor state. In this dome there is a liquid plus vapor state, and outside this dome, to the right of this dome, there is a vapor state. There is a vapor state, right? Therefore my dear students, we can say at critical point, here liquid directly flashes to vapor. At critical point liquid directly flashes to vapor, and latent heat of vaporization is 0. And option C is saying that the ice directly converts to solid. No my dear students, the ice directly converts from solid phase to vapor phase. No, here liquid is converting from solid phase to liquid is converting into vapor. That means water is converting into vapor. Water is converting into vapor. At critical point, water is directly converting into vapor. But here they are mentioning ice is directly converting into vapor. This is wrong statement. Therefore, option C is a correct choice. Option C is a correct choice because option C is wrong statement here. The third question in today's lecture, that is theory question, is this question was asked in GATE 2015 for 1 mark in set 2. The question is, the van der Waals equation of state is given. Van der Waals equation is used for real gases is given P plus A by V square into V minus B is equal to RT, where P is pressure. Now my dear students, in this equation, here they have provided the equation. In this equation, P is pressure, therefore unit of pressure is Newton per meter square, right? Then V is specific volume. Here V is specific volume. The unit of specific volume is meter cube per kg. Then T is temperature and R is characteristic gas constant. Now T is temperature. Therefore for temperature unit is Kelvin, and R is characteristic gas constant. Therefore unit of R, that already we have seen in basics. R is joule per kg Kelvin. Joule per kg Kelvin. Right. Now the SI unit of A. Now what will be the unit of A? They are asking. Right. Let us find the unit of A. They have provided few options. Now my dear students, here we are going to find this unit. The equation here, equation is P plus A by V square into V minus B is equal to RT. Now my dear students, take a simple example. If I tell you 5 meter plus 2 kg, then is equal to what? Now you will say it is not possible. The meter will never add into kg. Right? This is not possible. Now if I say 5 meter plus 2 meter is equal to how much? You will say 7 meter. Definitely, because same units will get added as well as the same units will get subtracted. Means addition and subtraction of same unit is only possible. Therefore, here there is an addition of pressure with A by V square. Therefore, whatever may be the unit of pressure, the same unit must be for A by V square. That basic idea we will get from this, right? So, the unit of A by V square here, as P plus A by V square is written as pressure in Newton per meter square, then this A by V square must be in Newton per meter square. Therefore, one thing we got here, the unit of A by V square is Newton per meter square. So let us find here A by V square is equal to Newton per meter square, and V is nothing but specific volume, that is meter cube per kg. It is given in meter cube per kg. So let us put there. Therefore, unit of A will be equal to Newton per meter square into specific volume unit is meter cube per kg whole square, because it is volume square, right? Therefore, unit of A will be equal to Newton per meter square into here meter cube power 2 means meter power 6. Therefore, meter power 6 divided by here kg square. There is a kg square divided by, we can say, kg square. Therefore, A is equal to Newton into this meter square will cancel 2 meters here. Therefore, in numerator meter power 4 divided by kg square. Right. This will be the unit of A. But my dear students, we know that as per Newton's second law, force is equal to mass into acceleration, and the unit of force is Newton, unit of mass is kg, and unit of acceleration is meter per second square. Therefore, we can say 1 Newton is equal to 1 kg meter per second square. Therefore, instead of this Newton, we can put kg meter per second square. So let us replace this Newton by kg meter per second square. Therefore, the simplified unit of A will become A is equal to Newton is nothing but kg meter per second square into meter power 4 divided by kg square. Therefore, 1 kg will get cancelled. Right here, meter power 5 divided by kg second square. This will be the unit of A. So let us observe the options. In option C, meter power 5 divided by kg second square. Therefore, option C will be the correct choice. The next question, this question was asked in GATE 1993 for 1 mark. The question is, the relationship dou T by dou P at constant enthalpy is equal to 0 holds good for options: an ideal gas at any state, a real gas at any state, any gas at its critical state, any gas at its inversion point. Now, my dear students, this Joule-Thomson coefficient mu is nothing but change in temperature with respect to change in pressure at constant enthalpy. For throttling process, Joule-Thomson coefficient is mu, which is nothing but change in temperature divided by change in pressure at constant enthalpy. And whenever this Joule-Thomson coefficient is 0, then the point is called inversion point. Now, my dear students, these concepts I have taught in refrigeration subject, because there is one refrigeration topic, or there is one refrigeration method called Joule-Thomson coefficient, Joule-Thomson refrigeration method. And in refrigeration cycles, I have taught this concept in types of refrigerations or various methods of refrigeration, where there is one method called Joule-Thomson refrigeration. Whenever this Joule-Thomson coefficient is 0, the point is called inversion point, right? Therefore, this relation holds good at inversion point. Therefore, for this question, answer D is correct. My dear students, the solution and the concept of this question you will find in RAC topic, refrigeration and air conditioning topic, where I have taken one topic called methods of refrigeration. But my dear students, here in this topic we have seen throttling process. That's why I have considered this question in this topic, because this is called Joule-Thomson coefficient. That also I have explained in this topic. The next question is, this question was asked in GATE 1993 for 1 mark. Simple question. During the phase change of a pure substance, dg is equal to 0, dp is equal to 0, dh is equal to 0, du is equal to 0. Now, my dear students, let us understand phase change. phase change, already we have seen in theory lectures, phase change is nothing but pressure remains constant, temperature remains constant, as well as Gibbs function remains constant. Gibbs function is nothing but G. G is nothing but H minus Ts, right? This Gibbs function is also constant, and I have already explained this concept in the topic. Now, my dear students, therefore, change in pressure is 0. Pressure is constant means change in pressure is 0. Change in temperature is also 0, and change in Gibbs function is also 0, right? But here they have given Gibbs function 0, change in Gibbs function 0, change in pressure 0, change in enthalpy 0, change in internal energy 0. Now here from this you may say that option A as well as option B are correct. But my dear students, here only option A is 100% correct. Here we can say option B is half correct. Option A is 100% correct, because this Gibbs function G, this Gibbs function is G is nothing but H minus Ts. Therefore, change in Gibbs function will be dH minus Tds minus S dt. This is the mathematics, right? Therefore, this change in Gibbs function is equal to dH minus Tds is nothing but heat. Therefore, dH minus dq, right, minus S dt, right? Therefore, again after this we know that enthalpy H is equal to U plus PV. Enthalpy is equal to U plus PV. Therefore, change in enthalpy is equal to du plus we can say PdV plus VdP. This is how we are doing partial derivative. Pressure constant, derivative of volume, volume constant, derivative of pressure. Here this du plus PdV is nothing but heat. Du plus PdV is nothing but PdV is work, and internal energy plus work is heat. Therefore, dH is equal to dq plus VdP, right? Therefore, dH minus dq is equal to VdP. dH minus dq is VdP. Therefore, replace here. Therefore, dg will become equal to dH minus dq is VdP minus S dt. Therefore, from this we can say the change in Gibbs function is VdP minus S dt, right? My dear students, from this we can say change in Gibbs function dg is equal to VdP minus S dt. And my dear students, during phase change, the change in pressure is also 0. During phase change, change in pressure is also 0, right? And here S dt, S dt, S dt, we have to say S dt, right? During phase change, change in pressure is also 0 and change in temperature is also 0. That means change in Gibbs function is 0, and whenever change in Gibbs function is 0, then change in pressure is always 0 and change in temperature also 0. Therefore, here for phase change, all these conditions must satisfy, and whenever Gibbs function is constant, that is change in Gibbs function is 0, then change in temperature as well as change in pressure is always 0. Therefore, here option A is correct choice. The next question on this topic is, this question was asked in GATE 1993 for 1 mark. The question is, at triple point of pure substance, the number of degree of freedom is. Now, my dear students, in question they have mentioned it is a triple point, and triple point is a point where substance exists in all the three phases. That is, there will be a solid phase, there will be a liquid phase, as well as there will be a vapor phase at triple point of any substance. Therefore, here P is represented as number of phases. P is number of phases. Therefore, number of phases will be 3. That is solid, liquid, and vapor. Now, again in question they have mentioned that pure substance, of a pure substance. Pure substance is nothing but single component. The meaning of pure substance is single component. Here we can say it is a single component. Therefore, the number of components are, that is number of components are represented by C is equal to 1. Now they are asking the degree of freedom is. At this triple point, degree of freedom is represented by capital F. So this degree of freedom is equal to how many? Right, F is equal to question mark. Now my dear students, we have Gibbs phase rule. Now this Gibbs phase rule says that as per this Gibbs phase rule, degree of freedom plus number of phases is equal to number of component plus 2. F plus P is equal to C plus 2. From this we can calculate F is equal to C plus 2 minus P, which is equal to C is 1 plus 2 minus 3. Therefore, degree of freedom is equal to 0. Therefore, my dear students, at triple point of any pure substance, degree of freedom is 0. And water is a pure substance, H2O. That is, the mixture of ice plus water vapor is a pure substance, right? Therefore, at this state, we have solid, liquid, as well as gaseous form, but it is only one component as it is pure substance. Now the next question is the constant pressure lines in a superheated region of a Molière diagram will have. Now let us understand about Molière diagram. Molière chart is nothing but HS diagram. Here if I draw enthalpy versus entropy diagram, on y-axis enthalpy and on x-axis entropy, and the Molière diagram, Molière chart will be like this, that is liquid vapor dome will be like this. Now to this dome, the left of this dome will be having liquid state, in between dome there will be a liquid plus vapor state, and to the right of this dome there will be a vapor state, right? Now my dear students, the constant pressure lines in superheated region on the Molière diagram will have. Now on Molière diagram the constant pressure lines are represented like this. These are the constant pressure lines. Here pressure is constant, right? In superheated region means, in vapor region. Now see, in vapor region, as for constant pressure, as enthalpy is increasing, entropy is also increasing. Therefore let us understand this slope. As x coordinate is increasing, change in entropy is positive, then y coordinate is also increasing, that is change in enthalpy is also positive. Therefore here dh by ds, which is nothing but change in y coordinate divided by change in x coordinate, is nothing but slope of Molière chart. Therefore here change in h is positive when change in s is also positive. Therefore the slope will be positive. In superheated region slope will be positive. Therefore option A is correct choice, a positive slope. Now the next question was asked in GATE 1996 for 1 mark. Again it is a theoretical question. The question is, when wet steam flows through a throttle wall and remains wet at exit. Now here the wet steam is flowing through throttle wall. Therefore the process is throttling. Let us understand here. Let us say the wet steam at pressure P1 and temperature T1 having some quality x1, dryness fraction x1. Now this wet steam is flowing through a throttle wall. Let us say this is a throttle wall and remains wet, means the pressure will become P2, temperature will become T2 at exit, and dryness fraction will be x2. It is quality will be x2. Alright. Now here the process is throttling, then remains wet at exit. Then the options are its temperature and quality increases, its temperature decreases but quality increases, its temperature increases but quality decreases, its temperature and quality decreases. Now here they are asking about temperature and quality. Now my dear students, for throttling, remember this throttle wall is nothing but throttling process. This is called throttling process. Throttling process is nothing but isenthalpic process. That means during this process enthalpy is always constant. Means number one, enthalpy is constant, means H1 is equal to H2, which is nothing but enthalpy is constant. This is very important. Now second point, due to throttling, pressure always decreases. That means initial pressure is always more than final pressure. That means we can say pressure always decreases because of throttling. Now third point, due to throttling, entropy always increases. That means initial entropy is less than final entropy. Therefore my dear students, due to throttling, entropy always increases. This is very important. Due to throttling, enthalpy is always constant, entropy always increases, pressure always decreases. Right. Now my dear students, again due to throttling, the fourth point, the quality always increases. Due to throttling, quality always increases because due to throttling, the specific volume in the exhaust is increasing. That means specific volume is increasing. That means density is a reciprocal of specific volume. Therefore, density is decreasing. Density is reciprocal of specific volume. Therefore, density is decreasing. Here, density is decreasing. Therefore, specific volume is increasing. Means vapor content is increasing. And my dear students, this quality X is nothing but mass of vapor divided by mass of liquid plus mass of vapor, right? And here due to throttling, mass of vapor is increasing and mass of liquid is decreasing, therefore quality is increasing. And as mass of vapor is increasing, therefore specific volume is increasing, right? This is the throttling process, right? Now my dear students, let us understand for temperature. Here number one is quality always increases. So let us check the option. Here in first option quality increases, in second option quality increases, in third option quality decreases, fourth option quality decreases. Means definitely option C and option D are wrong. Now let us observe for temperature. Now my dear students, for throttling, this throttling is given by the temperature pressure behavior is given by Joule-Thomson coefficient. And here this Joule-Thomson coefficient mu is nothing but change in temperature with respect to change in pressure due to throttling, that is at constant enthalpy, right? And my dear students, due to throttling, pressure is always decreases means change in pressure, that change in pressure is always negative. Pressure is decreasing means change in pressure is negative, right? If this mu is positive, if this mu is positive, that means change in pressure is negative, then this change in temperature must be negative, right? Therefore this change in temperature must be negative, hence temperature decreases. And my dear students, for steam this Joule Thomson coefficient is positive. For steam this Joule Thomson coefficient is positive, hence due to throttling of steam temperature always decreases. Due to throttling of steam temperature always decreases. So here option B is correct, its temperature decreases but quality increases. Therefore here option B will be the correct choice, right? My dear students, for ideal gases due to throttling temperature is constant. For ideal gases due to throttling temperature is constant because Joule Thomson coefficient is 0. For ideal gases, see here I will say, for ideal gas due to throttling this Joule Thomson coefficient mu, which is nothing but change in temperature divided by change in pressure, is 0. It is for ideal gases, right? Therefore temperature remains constant, that is change in temperature is 0, right, for ideal gases. And for real gases due to throttling temperature may increase, may decrease, or may remain constant. That depends on the value of Joule Thomson coefficient. If this Joule Thomson coefficient is positive, then temperature decreases. If this Joule Thomson coefficient is negative, then temperature increases. And if this Joule Thomson coefficient is 0, then temperature remains constant. The last question in the today's lecture is, this question was asked in GATE 2007 for 2 marks. Actually this question is from basic thermodynamic subject, but here I am taking this subject in properties of fluid, because in this question only we have seen Joule Thomson coefficient. That's why this question I am considering in this subject. Only this P we know here. From this subject or from this topic we know only about P point, but Q point, R point and S point are from basic thermodynamic subject, right? But here I will tell you answer, and if you have confusion in my answer, then you can go back in your basic thermodynamic subject and watch the videos, right? Now here one by one, the which combination of following statement is correct, which of the following statements are correct, that we have to check. Number one, a gas cools upon expansion only when its Joule Thomson coefficient is positive in the temperature range of expansion. Now, just now we have seen, when your Joule Thomson coefficient, that is change in temperature with respect to change in pressure at constant enthalpy, is positive, then temperature always decreases, means cooling effect. Temperature decreases means cooling effect. Therefore, here they are saying a gas cools upon expansion only when its Joule Thomson coefficient is positive. Therefore this statement is 100% correct. This statement is 100% correct. Therefore we can say P is correct, right? Now just now in previous lecture or previous question we have seen this P statement. Now Q statement, for a system undergoing a process its entropy remains constant only when the process is reversible. Now my dear students, entropy remains constant for a process only when the process is reversible. Now this is a wrong statement. This is a wrong statement, because my dear students, here for reversible adiabatic process heat is 0. Therefore here heat is nothing but TdS. Therefore ds, change in entropy, is equal to Q by T, is 0, right? dQ by T is 0. So my dear students, change in entropy 0 means entropy is constant. So my dear students, entropy is constant only for reversible adiabatic process, also called isentropic process, but my dear students, for other reversible processes entropy changes, such as reversible constant pressure process, there will be an entropy change. For reversible isothermal process there will be an entropy change. For reversible constant volume process there will be an entropy change, right? For rest all reversible processes entropy changes, but only for reversible adiabatic process entropy is constant. And here in this option they are saying, here for the system undergoing process its entropy remains constant only when the process is reversible, which is absolutely wrong. Here if they mention you for instead of this word, if they mention you reversible adiabatic process, then the statement will be correct, right? Only reversible is not correct statement, right? Therefore Q is wrong. Now here R, the work done by a closed system in an adiabatic is a point function. The work done by a closed system in an adiabatic path, here adiabatic process they are saying, right, is a point function. Now generally work is a path function. You have studied this in basic thermodynamics subject, work is a path function, right? but we have to understand this what they are saying actually, right? Q is wrong. Now for closed adiabatic system, closed adiabatic, closed adiabatic system, right? That means non-flow process, non-flow adiabatic work. Therefore work non-flow, work 1 to 2 will be equal to P1 V1 minus P2 V2 divided by gamma minus 1. This is the formula. Therefore work 1 to 2 we can say P1 V1 is MRT1, therefore MRT1, P2 V2 is MRT2, therefore MRT1 minus T2 divided by gamma minus 1. Therefore work 1 to 2 is equal to M, here R divided by gamma minus 1 into T1 minus T2. And my dear students, I have taken one lecture, that is thermodynamic relations, right? That is ideal gas relations. In this lecture we have seen that this R divided by gamma minus 1 is CV, specific heat at constant volume. Therefore this work will be equal to mcv T1 minus T2. And my dear students, mcv dt is nothing but internal energy. Therefore we can say here work 1 to 2 is equal to U1 minus U2, that is change in internal energy. Therefore we can say work is equal to change in internal energy. And my dear students, internal energy is a point function. This internal energy is a point function, right? Therefore only for closed system adiabatic work, for closed system adiabatic work is a point function, but rest of all processes the work is path function, right? Here internal energy is a point function, hence this work becomes point function, but for rest all processes the work will be the path function. Here this statement R is correct because they have mentioned here adiabatic path. Because of this adiabatic work this statement is correct, right? Now let us say statement yes, a liquid expands upon freezing when the slope of its fusion curve on pressure temperature diagram is negative. Yes, correct. Yes, correct. You have observed this phenomenon. Now my dear students, take a water bottle, fill the water bottle full of the water, take a full of water in the bottle, and then close the tap of this water, or let us put this full of water bottle in the fridge and observe the ice will come out. Why? Because on freezing there is a expansion, on freezing there is a expansion, and this expansion is because the fusion curve is having negative slope, right? This is a triple point concept. This statement is also correct, my dear students. This statement is also correct. Therefore here only Q is wrong, and here P R E S are correct. Here P R E S are correct. Now my dear students, if you observe the options, none of the option is matching the choices, right? So my dear students, for this question in 2007 they have given wrong choices. Later they have cancelled this question because the question is wrong, right? Because here P R yes all are correct, the question is wrong, hence they cancel this question later, right? Thank you dear students. In next lecture we will see one more numerical on this topic.